And when numbers are very big or very small, they become difficult to manage. There's a lot of characters, a lot of digits in them. And so in science, we've come up with a way to represent these numbers more easily, and it's called standard form or scientific notation. Here's an example of a reasonably big number. It's 90 million kilometers, and it's the distance to the sun. That's my artistic effort. So the way it's written in scientific form, it's written in A times 10 to the power of n, where A is greater than or equal to 1 and less, that's supposed to be A there, and less than 10. And the n is an element of an integers, z. So in other words, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and minus numbers as well. So 90 million miles, which is the distance to the sun, is written like this: 9 multiplied by 10 to the power of 7. Now, why is it 10 to the power of 7? Well, 9 because we went back to here to find the first digit. And then, so we put a decimal point here. And then we see 1, 2, 3, 4, 5, 6. We count how many tens, how many times we need to move the decimal place forward to turn it into a scientific notation number. So 9 by 10 to the power of 7. Another example, 78,000. That would be written as 7.8 times 10 to the power of 4, because again we start with our decimal point here, which is 7.8, and we would have to move it 1, 2, 3, 4. Let's do one more example. Say 86, and I've got 1, 2, 3, 4, 5 zeros. That would be 8,600,000 as it happens. That would be written as 8.6 times 10 to the power of 6. So our decimal point would be here. Once, twice, 3, 4, 5, 6. So that's the way standard form is done. Now let's deal with small numbers and see how they work. So small numbers. So here's an example of one, 0.000056. Again, it has to be written in the terms of A times 10 to the power of n, where A is between 1 and 10 and so on. So that's going to be given 5.6 times 10 to the power of. And my decimal point is here, 5.6. Now I have to move it back. 1, 2, 3, 4, 5. So that's going to be 10 to the power of minus 5. 10 to the power of minus 5. Let's have a look at another example now. 0.0034. That's equal to 3.4 times 10 to the power of, there's my decimal point, 1, 2, 3, minus 3. And I'll do one more example like this, 0.000003. And that's going to give me 3 times 10 to the power of, my decimal point now is here. So that's where my decimal point is here, so that's where it will be there. And I'm counting back once, twice, 3, 4, 5, 6, 7. So it's 10 to the power of minus 7. You may need to pause and look at this one again, and maybe the large numbers too, to get an idea. I'll give you a bit of practice in a few minutes as well. We need to be able to convert these numbers back as well. So here are a couple of big numbers here and a couple of small numbers here. So how do we convert them back? Well, this is going to be, we know it's going to be 2, 3, and I'm going to have to move the decimal point forward 4 times. So what I typically do is I write a number of zeros down. I don't actually count them too much, and I'm going to be counting. I need to move the decimal point forward 4 times. So it's here now, isn't it? There. So it's going to go 1, 2, 3, 4 times. So actually I got it right. So it's 23,000. My decimal point will go here. We typically don't write decimal points and big numbers, like we don't write 90 million point 0. So it's 23,000. Let's do the same with this one. It's equal to 472. I need to move the decimal point forward 6 times. So let's try that. I may need another 0. That's fine. So 4.72. The decimal point starts there. Once, twice, 3, 4, 5, 6. Excellent. So that's equal to 4,720,000 is the answer to that one. Let's do a small number. So now I've got 5 multiplied by 10 to the power of minus 4. Now it's going to be, I write down my 5, and I'm going to need a number of zeros beforehand because I'm moving my decimal point back. So I can put a number of zeros down, and I'm going back 4 times. Now my decimal point is here, currently, 5, you see. I'm going once, twice, 3, 4. So my decimal point is going to go in there. So it's 0.0005. And I'll do this one. 532. So I'm writing my 532 here. It's a small number, 10 to the power of minus something. 6, it's going back. Right, okay. So I put lots and lots of zeros in. I probably won't need all of these. And now I'm going minus 6. I'm starting here because it's 5.32. So the decimal point kind of starts in the same position. And now I move back 6 times. Once, twice, 3, 4, 5, 6. That's just coincidence. I actually expected to have a few more zeros that I wouldn't need. So that could just be a rough work. If you're doing it in a test, you might then write it out nicely without all the red squiggles. But that'll be fine too. Make sure you leave a gap between the zeros so when you put your decimal point in, it stands out as being a decimal point. And I used to always do this, put all my zeros really close together, and then you couldn't get the decimal point in. It wouldn't be obvious, Okay, when you're adding and subtracting numbers which are written in scientific notation or standard form, you have to convert them back to ordinary, normal decimal numbers. So 5.6 by 10 to the power of 3 is equal to 6. And then I move my decimal point forward 3 times. So once, twice, 3 times. So it's 5,600 plus 2, 3. So 2, 3, and put a few zeros in. And I need to go forward 4 times. So once, twice, 3, 4. So it's 23,000. So I add these up together, 23,000 and 5,600. Oops, that's very messy, isn't it? Anyway, 00682. So 28,600. And then I might want to convert that back into standard form again. So it's going to be 2.86 times 10 to the power of once, twice, 3, 4. 10 to the power of 4. Okay, good. Now we need to learn how to multiply and divide numbers which are in standard form. So here is an example. We've got 3 multiplied by 10 to the power of 2 multiplied by 8 multiplied by 10 to the power of 4. What we can do in this case is we can choose, because multiplication is commutative, it doesn't matter what we multiply by what. So we choose to multiply the 8 by the 10, or the 3 by the 10, 3 by the 8, and the 10 by the 10 to the power of 4. So 3 by 8 is 24, and 10 to the power of 2 by 10 to the power of 4 is equal to 10 to the power of 6, because we add our indices. So 24 by 10 to the power of 6, but you note that is not in standard form. It's 24, and 20. This number here has to be between 1 and 10. So it's going to be 2.4 multiplied by 10 to the power of 7. You might need to think about why does it change to 7. I mean, I divided the 24 by 10, so in order to keep the number the same, I multiplied this side by 10, so that all works out. Okay, let's do another example. We'll say 1.2 multiplied by 10 to the power of 4 times 4 multiplied by 10 to the power of 3. So it's 1.4, 4 multiplied by 1.2. I can multiply those together. That gives me 4.8 times 10 to the power of 4 multiplied by 10 to the power of 3 is equal to 10 to the power of 7. And that's good. And lastly, I'd like to do one more example. Okay, we'll do one more example like that. We'll say 3.5 multiplied by 10 to the power of 5 multiplied by 5 multiplied by 10 to the power of 3. So my 5 multiplied by 3.5 is 17.5 times 10 to the power of 8. And it's 10 to the power of 8 because I'm multiplying these, and the 5 and the 3 add up to 8. You need to check your indices if you don't remember that. And again, note 17.5 is not between 1 and 10, so this becomes 1.75 multiplied by 10 to the power of 9. We've increased the 8 to 9 because we've reduced it on this side. Okay, some division. Now, in this case, I'm going to divide 9 divided by 3 is going to give me 3. And then times 10 to the power of 4 divided by 10 to the power of 2 is equal to 10 to the power of 2. It's that easy. In this case, over on the right-hand side, 2.2 divided by 1.1 is equal to 2. And then 10 to the power of 6 divided by 10 to the power of 2 is equal to 10 to the power of 4. When we're dividing, remember, 10 to the power of something or any indices, you subtract the indices. So, for example, 6 to the power of 7 divided by 6 to the power of 3. That's equal to 6 to the power of 4. because 7 take away 3 is 4. You're subtracting the indices. Don't forget your rules. Okay, now you need to practice these to make sure you understand this lesson. Pause the video, and in a couple of seconds time when you've got them done, you can press play again and you'll see the answers. So pause it now. Okay, here are the answers. Now finally go on to the last page, which deals with some adding and multiplication. Okay, same thing. Have a go at these 3 questions as well. Write them down. Pause the video, and when you restart it in a couple of seconds, you'll be able to see the answers. Good luck. Okay, so this is the end of the lesson. You may need to go over the video again and try to do the questions yourselves, because when you come into class on Monday, the plan is that we will just do practice of these in a bit more detail and more kind of exam type of questions. So hopefully this will work. We'll check it out and see you guys. Have a nice weekend, and I'll see you Monday.